Hello, in this video we'll be showing how to determine which technique to use when working with difficult integrals.
So we have the problem integral secant cubed dx. And initially we can look at doing it by splitting it up into integral secant squared times secant dx and do trig identity. But if we did it, it would end up being extremely complicated. So another way of looking at it is doing integration by parts and doing the necessary steps in order to do that. And you'll see that if you set u equal to secant and dv equal to secant squared, you'll see it becomes a lot simpler. And as you go through the problem, you'll eventually need to be using trig identity for the minus integral after you put it into integration by parts. And then you don't want to forget about a little algebra, which you'll be doing the minus integral, but whatever you get is going to be minus in parentheses integral, if that makes sense. And that's just a simple algebra error that a lot of people might make. And after you do that, you would end up wanting to solve for secant dx, which you would end up needing to times it by 1 using the hint that was given to you by Miss Mung of timesing the top and bottom by secant plus tangent for both the numerator and denominator, and it would have to involve some sort of u substitution. And at the end, all that would be equal to integral secant cubed dx, but there's two of them, one on the left, one on the right, but the right side is negative. So you would add it, and then there would be two of them. So you would have secant 2 parentheses integral secant cubed, and in order to cancel that out, you have to divide the right side by 2, and that's basically how you would solve the problem.
Hopefully this video was helpful for showing when to use certain integral techniques. Thank you.